Electrolysis is the topic for today, for this week. Electrolysis. Confirm you can all see my whiteboard.
Yes, sir.
Yes, sir.
Okay. You can all see my. So let's start. So what do you understand by electrolysis? So you are required to know how to define it according to your syllabus. What is electrolysis? What are we trying to achieve? We are trying to separate what? Decomposition of a compound. Remember, a compound cannot be physically separated. So electrolysis is the decomposition, of an aqueous, aqueous means in water, of an aqueous compound, in fact ionic, was covalent, you can't, ionic compound, or molten ionic compound. Clear? Electrolysis is the decomposition of an aqueous ionic compound or molten ionic compound. Is the decomposition of molten or ionic compound. Why is that? Why is it we can't do electrolysis for covalent compounds? Why is it? I'm not saying write it down, I'm just asking. Why is it? It's nearly impossible for covalent compounds. What's the reason? Because covalent compounds do not have what? Freely moving what? Electrons. Covalent compounds do not have freely moving electrons. Are we together?
Yes.
Did the new student join us? So we can write covalent compounds cannot conduct electricity. Next point. Covalent compounds cannot conduct electricity. Hence, they do not undergo electrolysis. Covalent compounds. I hope you didn't write the wrong spelling here. Covalent compounds, like my spelling, which is wrong. Electrolysis. Covalent compounds cannot conduct electricity, hence they do not go under electrolysis. Clear? Next point is that the ionic compounds in solid state, ionic compounds in solid state, do they conduct electricity, ionic compounds in solid state? Do ionic compounds in solid state conduct electricity? No. Ionic compounds in solid state cannot conduct electricity because they don't have free ions. They do not have free ions. They are fixed in their positions, so they can't conduct electricity. So ionic compounds in solid state cannot conduct electricity. Hence, there are no free ions. Clear? So that's why we need to add water to make it ionic. If you add water, the electrons can freely move, the ions can freely move. Now, I hope it's making sense. Because a metal from your basic physics, or a metal has got positive ions, negative ions in a lattice structure, more like this, closely packed together in a lattice structure like this, negative, positive, something, say 3D lattice structure. So the particles are the particles are in fixed positions, closely packed. So because of that, it can conduct electricity. So now when we add water when we add the water, the ions can freely move. The positive and negative ions can freely move. Therefore, it can conduct electricity. Remember, current is the flow of electrons. Is that clear with everyone? So that's why we need to add water, or we heat the metal until it becomes a liquid. So molten means liquid state, no water. When we say molten, maybe you can write it down. It simply means liquid state, but no water. No water. You see why no water there. So it simply means the metal is in liquid state. The compound is in liquid state. We have heated the solid compound until it becomes a liquid. No water has been added. That's what we call molten state. So if we do that now, the electrons can freely what? The positive and negative can freely move. Clear? For example, your salt, sodium chloride, is like this. It is made up of the sodium positive and the chlorine negative. So in terms of this positive will be the sodium, and this will be the chlorine negative. So it will be difficult to draw something like, but this is negative, this is positive, and it goes, but they are closely packed. So now when you heat it, they can freely move and conduct electricity. Clear now? So let's look at some key terms that we need to know for the topic. This is just an introduction of the topic. Key terms. There are some key terms that you need to master by now. The key terms that we'll be using. So the first one is an electrode. An electrode. When you are doing electrolysis, we need to know what electrodes are. Clear?
Yes, sir.
An electrode is a rod of a metal. Normally we try to use an inert metal. A rod of a metal, mainly graphite and carbon. Mainly graphite and carbon because they do not easily react with the solutions. Mainly graphite and carbon because they do not, so mainly graphite and platinum, not carbon, because graphite is a form of carbon. Mainly graphite and platinum because they do not easily react with the solutions. Through which current flows in or out of an electrolyte. An electrode is a metal rod, mainly platinum or graphite, through which current flows in and out of the electrolyte. Then, so that's then the next term is electrolyte. Electrolyte. So this, you should know that, is the ionic compound, is the ionic compound either in liquid state, any compound in molten state or aqueous. Or aqueous state. That's the electrolyte, which is dipped, where electrodes are dipped into this. Then the anode. Anode is the positive electrode. Positive electrode is the positive electrode. Then cathode is the negative electrode. Negative electrode is what we call cathode. Are we together? Then an ion, so don't confuse it now. An ion. This anion is a negatively charged ion. Negatively charged ion. Then cation, cation, cation is the positively charged. Positively charged ion. Remember when we separate the, okay. Let's draw the diagram, then I'll talk about certain things here. So I'm not good at diagrams, but I'll try to show you. So maybe what you can get in an exam is something like this. So it's a bit of physics. Well, I'll explain why. No, we're adding physics concept into chemistry. Okay, so we've got our electrode here. Then we have, so you can try, but you can draw a nice diagram. Then we mention certain things here. Then this is my solution. So this solution, we say it is called the electrolyte solution. That's what we agreed, electrolyte solution. Clear? Now, which one is the positive and which one is your negative? But sometimes they won't just simply draw this. Which one is the positive and which one is the negative? Yeah, this is a battery. Which one? For my physics. The long one is always the positive. Clear? The short one is the negative. Therefore, if this, are we together? If this connects to the positive here, it means this is a positive electrode, and it's called an anode. Clear now? Then this is to the negative is the cathode. Are we clear? The anode. So the anode, which is positive, attracts, remember negative charges, the attractor, attracts the negative ions. This one attracts positive ions. Is that clear?
Yes, sir.
Okay. Now let's look at the mechanism now of electrolysis. Then we explain it as we go. So let's start with electrolysis of molten binary compounds. Electrolysis of molten binary compounds. I'm always writing wrong spellings here. Electrolysis of molten binary compounds. Electrolysis of binary compounds. Now, remember we said it's molten. So, if I look at sodium chloride, liquid, because it's in liquid state here. That's what we're talking about. So there are only two ions there that are present. There is sodium positive and there is chlorine negative. Chlorine group 7. This is group 1. So those are the only two ions present in the whole solution, but there are many of them. Clear now. Electrolysis of that. So if we're to do electrolysis of this, remember we said we've got the anode here and we've got the cathode. I'm not going to draw the diagram. You now know how the diagram looks. The anode and the cathode. So remember, this is binary, no water. So at the positive anode, which ions here will be discharged at this anode? From what you've said, this is a positive. Remember, anode is a positive electrode. So which ion between the two will be discharged? The
Sodium.
positive
Sodium.
anode always is a positive. It draws the negative electron. So chlorine ions are discharged. You can write that chlorine ions are discharged. But they are not only discharged, chlorine ions are discharged. But something happens to them. What do you think happens to the chlorine? Remember, chlorine ion, it has one excess electrons. Huh? They lose. So the chlorine ion loses an electron. It loses the one extra, loses an electron. So once it loses the electron, it forms the chlorine atom. Are we together? That's what happens. But unfortunately, chlorine is always diatomic. You should know that. Chlorine is diatomic. Clear now? So what's actually happening, because chlorine is diatomic, I'll write it like this. Let's think of what happens on the anode first. Is 2 chlorine negative, losing 2 electrons like this to form Cl2. It's diatomic. You never see chlorine as this in nature. It's diatomic. That's why I'm saying writing 2 Cl negative, Cl negative, minus 2 electrons is equal to that. But the convention now, we don't put a minus here. We put the 2 the other side. So that's why in your exam or in books, you see it will be like this. Cl2 plus 2 electrons. Clear? Making sense? Plus 2 electrons. So if they ask you for an observation of the electrolysis of sodium chloride or molten sodium chloride, what is chlorine gas? So we say observation, a greenish, chlorine is a greenish yellow gas. Huh? A greenish yellow gas is formed at the anode. That's the observation. A greenish yellow gas is formed at the anode. Clear? Greenish yellow gas, which is chlorine, is observed at the anode. Now let's look at the chemistry of what happens at the anode. at the anode. Sorry, at the cathode. You can tell that the sodium plus ion is discharged. There's one less electron, remember? Plus, it means it loses an electron. Sodium is discharged. Sodium plus ion is discharged and gains an electron. And gains an electron. Gains an electron. Are we together? When it gains an electron, what do we call the gain of an electron? Is that oxidation or reduction? Gain of an electron is what? Lila?
Oxidation.
Oxidation is not gain. It's gain of oxygen. Gain in oxidation state, it's a reduction. Huh? The gain in electrons is reduction. So it's the only, so it's a reduction. So reduction happens at the cathode. Reduction always happens at the cathode. Always happens at cathode. And the opposite is true. Oxidation always happens at the anode. Are we together? So reduction. So now let's look at the reduction, the process. So sodium plus, we said gains an electron to form the sodium metal. Clear now? Make sense? Now, what I'm going to do is let's look at this. We'll explain as we go. Let's look at some examples of binary compounds, electrolysis. So examples. What I'm going to do, which might not be in your book, is I'm just looking at the anode and cathode, then I'll look at the reactions. So at the anode, maybe let's look at examples. Let's start with, okay, magnesium oxide, liquid. Magnesium oxide. So this is a liquid, magnesium oxide. Okay. Magnesium oxide. So let's look at what happens at the anode and what happens at the cathode. So anode draws the negative charge. Anode draws, which is all oxygen. Oxygen is like this, negative charge. So remember we said it loses 2 electrons. And I said I don't like the minus here. I'll write it the other way. But unfortunately also, oxygen now does not exist as one like this. It exists as diatomic. So I have to put 2 here. Then plus 4 electrons. That's what happens. Clear?
Yes, sir.
So this is oxidation. This is from -2 to 0 increase. Oxidation. Clear? Oxidation. Now let's talk of what happens at the cathode. So magnesium, if you check your periodic table, is group 2, like this. So this gains 2 electrons to form Mg, like that. Clear now? Is that clear?
Yes, sir.
So these are known as half equations. Maybe that's what some people might find difficult. Half equations, and this is also another half equation. So now we can actually write the full ionic equations of what happens. That's what I want to look at now. the full ionic equation of this. We join them together. Just like what you do with simultaneous equations. Full ionic equation for what happens there. So can you see that there are 4 electrons here and these are 2 electrons? Let me write the equations together. So we have 2 O2 negative, 2 O2 plus 4 electrons. Then we have what? Mg 2 plus 2 electrons to form Mg like this. This is 4. So we need the electrons to balance. We multiply this equation by 2 like this. So that we have 4 electrons there. Then once we do that, now we now have 2 O2 negative, O2 plus 4 electrons. Then I have 2 Mg 2 plus 4 electrons. Remember, I'm multiplying everything by 2 to form 2 Mg. The electrons cancel out and we add the reaction like this. So when you are adding, we are simply adding the left side as it is, then the left side, the right side as it is. So if we add this, we simply have 2 Mg 2 plus 2 O2 negative to form, remember, that's this and that. Then the right hand side is simply 2 Mg plus O2. Done. That's a full ionic equation. Is that clear? Is Brandon there? Did he manage to join? No, they didn't manage to join. Talking about that or something. I think they are fixing it. Is that clear?
Yes, sir.
Yes.
Let's look at another example. So let's look at copper Cl2 liquid, liquid state, molten state. So if we do electrolysis of this, the anode, okay, then at the cathode. So at the anode, remember this is a positive charge, you know that, and this is a negative charged electrode. So this attracts the negative, which is chlorine. So Cl negative. But unfortunately, Cl exists as diatomic in nature like this. So we need 2 of them like that. So it has an extra electrons, it has to lose those electrons. So now it's now Cl2 plus 2 electrons like that. That's what happens. Clear? So it's oxidation, like what you said. Then at the cathode, the copper, which is a 2 plus, it has 2 plus, it means copper has lost 2 electrons because it's a metal, it gives electrons. So now it has to gain the 2 electrons to form copper again, like this. Clear now? This one is easy, so this is a reduction. So to write the full ionic equation is easy because the electrons are the same. Huh? So if we were to bring these equations together, so that we write the full ionic equations. The electrons cancel out. Then if you simply add, you are getting copper 2 plus 2 Cl negative to give you copper metal Cu plus Cl2. That's the full ionic equation. Is that clear then?
Yes, sir.
Where now this topic becomes tricky is what we call electrolysis of aqueous. Maybe let's just do that. We'll just introduce it, then we'll look at it in deep the next chemistry lesson. Electrolysis of aqueous, that's where it becomes complicated. Electrolysis of aqueous compounds. It's not difficult, but there are certain things that you need to know. Electrolysis of aqueous compounds. Electrolysis of aqueous compounds. Clear now? So for example, if I look at this, sodium, I said I'm just going to introduce it. AQ means aqueous. So I no longer have sodium and chlorine ions present only because it's in water. What other ions do I now have? It's now dissolved in water. What are the ions? Water always splits to what? We need to know that. To H plus and hydroxyl ions. So I now have hydroxyl ions, and now I now have 4 ions. In aqueous solutions, we always have 4 ions. So in any aqueous solution, we always have this. As long as it's in aqueous, we always have hydrogen plus and hydroxyl, because water splits into an hydrogen ion and a hydroxyl ion. So now it now becomes complicated because now you have to think, of course, between the sodium and the hydrogen, which one will be displaced? Between the chlorine and the hydroxyl, which one is preferentially discharged? Are we together? Clear now? Because remember, we said the anode always draws the negative electrons, but we now have 2 negative electrons, this one and this one. So now there's a law in chemistry now to say which one will be discharged. That's where it becomes tricky now. Clear now? That's where it becomes tricky. So we use what is called the reactivity series. Are we together? So to determine which ions, you can write that down, to determine which ions are to be discharged in aqueous compounds, we use the reactivity series. We use the reactivity series. We use the reactivity series. Are we together? To determine which ions are discharged or in aqueous compounds, we use the reactivity series. Comma, the least reactive is the one that is always preferentially discharged. The least reactive is the one that is preferentially discharged. So the last thing that I'm going to do before we even look at how that works is to quickly, because there's time for geo, is to give you the metal. Isn't time for geo? Metal reactivity series. So metal reactivity series. Metal reactivity series. So we have potassium, we have sodium, we have lithium, calcium, magnesium, aluminium, zinc, Zn2 plus, we'll switch on to geo just now, iron, Fe2 plus, Fe3 plus. Then we have copper, sorry, before copper here, we have hydrogen, copper, and silver. So this is the most reactive. Yeah, I know it's time for geo. We're switching on to geo now. Who is that? So this is the most reactive. And this is the least reactive. Most reactive, least reactive. Clear now? Most reactive, least reactive. Okay. Let's stop there. We'll explain how that works in next lesson. You can switch on to geo.
Thank you, sir.
You're welcome.